Hello everybody! For those who don't know me, my name is Simone and today I will talk about the human-computer interaction ontology network. Human-computer interaction, or HCI, is a wide domain and a multidisciplinary area that involves a diverse body of knowledge and people with different backgrounds working together. Sometimes it can lead to semantic conflicts and knowledge-related problems. So ontologies are good tools to solve semantic and knowledge-related problems. And to investigate the use of ontologies in human-computer interaction, we performed a systematic literature review and found 22 ontologies that cover different but sometimes overlapping contents. The ontologies were built completely isolated, and none of them reused or even discussed how to reuse or integrate ontologies. And there are HCI aspects not covered by any of them. And we argue that HCI ontologies should be built incrementally in an integrated way, forming a network. And this motivates us to work on HCI-ON. I want to draw your attention to this figure, and here is our current version of HCI-ON. We designed HCI-ON to cover relevant HCI aspects and to provide knowledge to talk about the whole life cycle of HCI projects. As you can see, the ontology network adopt a three-layered architecture, and at the foundational layer we use UFO. Obfuscator cycles represent ontologies under development. Arrows represent the dependence relationship, indicating that the target ontologies concepts are reused by the sourced ontologies. Solid arrows indicate the reuse of concepts between domain ontologies and core ontologies, and dotted arrows represent the reuse of concepts or dependence relationship between domains ontologies. At our core layer we have HCIO. It is an ontology about human-computer interaction, and at the domain layer we have domain ontologies that were more specifics or cover sub-HCI domains. For example, we have an ontologies about the human-computer interaction under the cognitive engineering perspective and semiotic engineering perspective. We have design ontology that covers designed objects and artifacts and agents involved in the design, HCI design. We also have an ontology about HCI evaluation and about the user interface, modalities of interaction, and about the context of use. In this figure, as you can see, HCI-ON reduces HCI-ON's concepts, so the HCI-ON is an ontology network about software engineering. So HCI-ON is connected to HCI-ON. For example, to talk about an interactive computer systems, we need to talk about software and system. For example, to talk about user requirements, we need to talk about requirements and so on. And the red solid arrows represent HCI-ON reusing HCI-ON's core ontologies or core concepts. And the dotted arrows, red dotted arrows represent HCI-ON reusing HCI-ON's domain ontologies or concepts. Moving on, to evolve HCI-ON, ontologies can be built from scratch using dependence relationship So the concept needs to be grounded in UFO to keep the network consistency, and this is the procedure we adopted so far for example, for our core layer and all of our domain ontologies. In this figure, we have HCI design ontology. It is our ontologies that talks about the human-computer interaction design. It addresses design by connecting design aspects to HCI objects, and we use some HCI-ON concepts and concepts of our core ontology and from our domain ontologies about a user interface. Concerning the ontology instantiation, taking the Microsoft Visual Studio as an example, in an HCI design scenario, it is a design interactive software system. The team or person in charge of designing it sketched a prototype showing how Microsoft Visual Studio graphical user interface should be. This prototype encoded several HCI design choices, like the description of how a toolbar should look and be positioned on the screen. This toolbar is implemented as a Microsoft Visual Studio graphical user interface program, which is constituent of a designed interactive software system, or the Microsoft Visual Studio. What makes the Microsoft Visual Studio an HCI design object is the fact that it has a design specification describing its characteristics, and once it was created satisfying that specification, it realizes that. To make it clear how ontologies can be built from scratch using dependence relationship, imagine that an application needs an ontology about physiological computing, so we can reuse and extend the network conceptualization to create an ontology about the physiological computing. So we basically reused concepts and ground concepts on UFO to keep consistency and extends the conceptualization of the network as needed. The new ontology can use only needed concepts from the network. So now the application can use the ontology. Here it is another example, but now using domain ontologies. Imagine that now we need to talk about user interface for physiological computing. So the physiological computing user interface just need to reuse and extend the network conceptualization. So now we have a new ontology and the application can use it. Existing ontologies can also be added to the network by using dependence relationship, but it needs to be re-engineered in light of UFO. So we get a new ontology that is different from the one before the re-engineering. Now the ontology can be added to the network. Also, if two or more ontologies talks about the same domain, they can be merged and re-engineered as aforementioned and add to the network. Existing ontologies can also be added to the network as they are. by using an alignment relationship. In this case, the aligned ontology was not changed. Basically, in this case, we put the concepts of the aligned ontology and the network ontology in some level of equivalence. And in this case, the application which used the aligned ontology was not affected, since the aligned ontology was not changed. So we aligned the 22 ontologies we found to HCI-ON. Moreover, the benefits of using HCI-ON is that the HCI knowledge is organized, it is easier to reuse and to extend. It can be used as needed, for example, as a whole or just as extracts of it. Aligned ontologies can also use extracts of the network, and the application which used the aligned ontology was not affected. Finally, HCI-ON aims to provide a comprehensive conceptualization about HCI, and some of our envisioned applications are related to knowledge and semantic problems. For example, as a basis to design knowledge management systems and to annotate HCI documents for system integration and so on. And we have experienced the benefits of ONS by using HCI-ON in applications, and we are working on a knowledge-based solution to HCI design and evaluation. Thank you all for viewing my presentation. I would like to thank my colleague Murilo and especially my supervisors, Mona Lisa, for all of her support, and Falbo, who was always an inspiration.